The examples in this go with lesson 4.6, graphs of other trigonometric functions. Example 1, graph y is equal to 2 times the secant of 4x. Okay, so the secant is really the reciprocal function for the cosine, and I'm just going to keep that in mind. Okay, we'll start off finding the amplitude, the period, the phase shift, and the vertical shift, because these will all help me with my graph. Now, first of all, the secant has no amplitude because its range goes off to positive infinity and negative infinity. All right, the period for the cosine curve, the period is normally 2 pi, but you'll notice that we have a b right here, so this is going to be 2 pi divided by 4, which reduces to pi over 2. The phase shift, there's nothing in here for our c to be added or subtracted there, so we don't have a phase shift, and we don't have a vertical shift either because there's nothing back here added or subtracted. Okay, let's choose our angles. I'm going to do this much the same way that I did the sine and cosine graphs. We will start at 0 because there was not a phase shift. We're going to graph one complete period, so that's going to finish at pi over 2. And now I want to find this middle value right here, and I can do that by adding 0 plus pi over 2 and then dividing that by 2. That's going to give me pi over 4, which is going to be this angle right here. And now I need to find this angle in the middle and this angle as well. All right, I can find this one by adding 0 plus pi over 4 and then dividing by 2. That's going to give me pi over 8. And I can find this one down here by adding pi over 4 plus pi over 2. And dividing by 2. And that should give me 3 pi over 8. All right, let's look back at the equation so we can figure out how to set up our chart, because we're going to do this, remember, using the order of operations. We're starting right here in the middle. I need to multiply my angle by 4. So 4 times 0 is 0. 4 times pi over 8, that's 4 pi over 8, but that reduces to pi over 2. 4 times pi over 4, that's 4 pi over 4, but that reduces to pi. 4 times 3 pi over 8 is going to give me 12 pi over 8, but that reduces to 3 pi over 2. And 4 times pi over 2 is going to give me 4 pi over 2, but that reduces to 2 pi. This is good because this column right here is where all of my key points happen on my cosine curve. I've got zeros and I have a max and a min in there. Okay, the next thing I'm going to do is I'm going to take the cosine of that angle. Now, I know we're supposed to be drawing the secant. We're actually going to make the secant on there at the very last thing. So I'm actually going to draw my cosine curve and then put my secant curve in there with it. All right, so the cosine of 0 is 1. The cosine at pi over 2 is 0. The cosine at pi is -1. The cosine at 3 pi over 2 is 0, and the cosine at 2 pi is 1. And the last thing I want to do is I want to multiply that column by 2. All right, so 2 times 1 is 2. 2 times 0 is 0. 2 times -1 is -2. 2 times 0 is 0. And 2 times 1 is 2. That means the ordered pairs I'm going to plot are 0 and 2, pi over 8 and 0, pi over 4 and negative 2, 3 pi over 8 and 0, and pi over 2 and 2. Alright, let's see. Alright, so I'm going to make this one pi over 8, pi over 4, 3 pi over 8, and then pi over 2. I have a point at 0, 2, pi over 8 and 0, pi over 4 and negative 2, 3 pi over 8 and 0, and pi over 2 and positive 2. Now this is enough information for me to put in my cosine curve, which is technically not part of the graph, so I'm actually going to do this in dotted lines. But it is going to help me shape my secant curve, because right here where the cosine is equal to 0, the secant is going to be undefined. And since it's undefined, that means I should have an asymptote right here. So I'm going to put my dotted line in right here for my secant curve. Also right here, where the cosine is 0, the secant is going to be undefined. So I'm going to put another asymptote in right here. All right, and then all I have left to do is to put my secant curve in there. Right here at the maximum, I know my secant curve is going to be going in this direction right here. And there's another half over here, but we didn't draw the cosine curve over there, so I'm not going to add it in there. Here's another maximum. The secant curve is going to be going up just like this. And again, there's another piece over here doing this. But since we didn't go any further than pi over 2, I'm not going to include that. And finally, down here at the minimum, my secant curve is going to do something like this right here. And there we have it in red, 2 secant 4x. Example 2, graph y is equal to the cosecant of x plus pi minus 2. All right, let's start off. We're looking for the amplitude, the period, the phase shift, and the vertical shift. Our amplitude, there is not going to be one. And again, this is because the range goes off to positive infinity and negative infinity. The period, the reciprocal function for the cosecant is the sine. And the period on the sine is normally 2 pi. And the coefficient over here is going to be 1, so b is equal to 1, which means the period on my function is going to be 2 pi. The phase shift, right here, we're going to go to the left, pi. And then our vertical shift, right here, means we're going to go down 2. All right, let's make our chart. The phase shift was negative pi. And we want to graph an entire period here, so let's see, negative pi plus 2 pi, that's going to give me a positive pi, so we're going to finish at pi. All right, let's get our 3 interior angles here. Exactly halfway in between these, that's going to be 0. Halfway in between negative pi and 0, we can figure that out by adding 0 plus negative pi and dividing it by 2, but that's just going to give me negative pi over 2. And then this one in here we can find by adding 0 plus pi and then dividing by 2, but that's just going to give me pi over 2. Okay, first thing we want to do is take our angle and add pi. Negative pi plus pi is going to give me 0. Negative pi over 2 plus pi, that's going to give me pi over 2. 0 plus pi, that's going to give me pi. Positive pi over 2 plus pi, that's going to give me 3 pi over 2. And then pi plus pi is going to give me 2 pi. Okay, now instead of taking the cosecant, I'm going to take the sine, because like the secant curve, I'm going to draw the sine curve in here, and then I'm just going to sketch the cosecant on top of it. All right, so let's take the sine of x plus pi. And by the way, we know we're ready because this column right here has all of my key points for the sine curve. I've got my maxes, my mins, and my zeros in there. All right, the sine at 0 is 0. The sine at pi over 2 is 1. The sine at pi is 0. The sine at 3 pi over 2 is negative 1. And the sine at 2 pi is 0. Remember, these numbers come from the unit circle. They're the y-coordinate for these angles. All right, and then I'm going to subtract 2. 0 minus 2 is going to give me negative 2. 1 minus 2 is going to give me negative 1. 0 minus 2 is going to give me negative 2. Negative 1 minus 2 is going to give me negative 3. And 0 minus 2 is going to give me negative 2. Our ordered pairs will be negative pi, negative 2. Negative pi over 2, negative 1. 0, negative 2. Positive pi over 2, negative 3. Pi, negative 2. All right, let's come over here and scale this. We can call this one negative pi over 2, and then this one will be negative pi, and then this one will be positive pi over 2, and this one will be positive pi. All right, negative pi, negative 2 is going to be right here. Negative pi over 2, negative 1 is going to be right here. 0, negative 2 is going to be right here. Pi over 2, negative 3 is going to be right here. And then pi, negative 2 is going to be right here. So my sine curve, I'm going to change colors here for just a second. Let's put it in here in gray. My sine curve is going to do something like this right here. All right, now let's go back and put the secant in there. All right, when the sine is equal to 0, the secant is going to be undefined. And it was 0 at negative pi, which means that we need an asymptote right here. The sine was 0 at positive pi here, which we got from 0. So that means right here on the x-axis, we're going to need another asymptote right here. And then the sine was 0 at 2 pi, which goes with the pi here. So we're going to need another asymptote right here. And we're ready to sketch our secant curve in there. At the maximum, the secant is going to open up in this direction right here. And at the minimum, and you won't be able to see this very well at all, the secant is going to open down just like that right there. Example 3, graph y is equal to 4 times the tangent of pi over 2 times x. Go over here and pick out my amplitude and my period and the phase shift and the vertical shift to graph these. The tangent, like the secant and the cosecant, does not have an amplitude because the range goes from negative infinity to positive infinity. The period on the tangent curve is pi. So unlike the sine, the secant, the cosecant, and the cosine, instead of being 2 pi, the period on the tangent and the cotangent is pi. But the formula is still the same. We're still going to divide that by the b, which is the coefficient on my angle. In this case, that's the pi over 2. So we have pi divided by pi over 2, which is the same thing as pi times 2 divided by pi. And they'll cancel, and that means the period on this curve is just going to be plain old 2. There's not a phase shift because there's nothing in here being added or subtracted to that angle. And there's not a vertical shift because there's nothing back here added or subtracted to my trig function. All right, let's go pick our angles that we're going to use. The special angles for the tangent, we have 0, pi over 4, pi over 2, 3 pi over 4, and pi. That all includes asymptotes, a 0, and a max, well, not a max and a min, but 2 other points that are nice to graph because they give us nice, pretty integer numbers. Okay, I'm going to start at 0 because there was no phase shift, and then we're going to finish at 2 because that was the period. Halfway in between 2 and 0, that's 1. Halfway in between 0 and 1, that's a half. And halfway in between 1 and 2, that's 1 1/2 or 3 halves. All right, the next thing we want to do is we want to multiply that angle times pi over 2. So pi over 2 times 0 is 0. Pi over 2 times a half, that's pi over 4. Pi over 2 times 1 is going to give me pi over 2. 3 pi over 2 times pi over 2 is going to give me 3 pi over 4. And 2 pi times pi over 2 is going to give me 2 pi over 2, but that reduces to pi. And this was very nice because this column right here has all of my key angles for the tangent curve. And the next thing I'm going to do is I'm going to take the tangent of that column right there. All right, at 0, the tangent, that's the sine divided by the cosine. So that's 0 divided by 1, that's 0. The tangent at pi over 4, that's going to be the square root of 2 over 2 divided by the square root of 2 over 2, that's 1. The tangent at pi over 2 is going to be 1 divided by 0, that's undefined. The tangent at 3 pi over 4 is going to be negative, it's going to be square root of 2 over 2 divided by negative square root of 2 over 2, which is going to give us a negative 1. And then the tangent at pi is going to be 0 divided by negative 1, which is just going to give us a 0. And finally, we're going to multiply 4 times that column. 4 times 0 is 0. 4 times 1 is 4. 4 times undefined is still going to be undefined. 4 times negative 1 is negative 4. And 4 times 0 is 0. Our ordered pairs we want to graph. We want 0, 0, 1/2, 4. At 1, we're going to be undefined. At 3 halves, we're going to be at negative 4. And then at 2, we want to be at 0. Okay. We have a point at 0, 0. Okay, we can do that. We'll call this one 1. This is 2. This is 3. And this is going to be 4. All right, so at 1/2, we're going to go up 4. At positive 1, it's undefined. That means asymptote, y'all. At 3 halves, we're going to be at negative 4. That's going to be down here. I guess y'all can't see that. There's going to be a dot down there. And then at positive 2, we want to be back here at 0. All right. So our tangent curve is going to do something like this right here. And that's it. Example 4, graph y is equal to the cotangent of x plus pi over 2 minus 3. The amplitude, there's not going to be one. This is a cotangent curve. The period, remember the normal period for tangent and cotangent is pi. We divide that by b, but that's just 1, so the period's going to be pi. The phase shift is going to be to the left, pi over 2. That's right here. Remember, it's negative c divided by b, which would be negative pi over 2 divided by 1, which would give me negative pi over 2. And then our vertical shift, back here it is, down 3. All right, let's go and pick our angles. The cotangent is going to have the same key angles that the tangent had. So I'm looking for 0, pi over 4, pi over 2, 3 pi over 4, and 2 pi. All right, we are going to start this one at negative pi over 2. And we want that period to be pi, so let's see, negative pi over 2 plus pi, that's going to give me positive pi over 2. So that means we're going to stop this thing at positive pi over 2 to draw one period. All right, halfway in between, this is going to be 0. Halfway in between here, this is going to be negative pi over 4. And halfway in between here is going to be positive pi over 4. And if you're wondering, all I did was 0 plus negative pi over 2, and that gave me the negative pi over 4. And then I did pi over 4 plus pi over 2 over 2. Wrong. Sorry. I did 0 plus pi over 2 over 2. And that gave me pi over 4, positive pi over 4. Okay. Order of operations, right here. Take your angle, add pi over 2. Negative pi over 2 plus pi over 2 is going to give me 0. Negative pi over 4 plus pi over 2 is going to give me positive pi over 4. 0 plus pi over 2 is going to give me pi over 2. Pi over 4 plus pi over 2, that's going to give me 3 pi over 4. And pi over 2 plus pi over 2 is going to give me 2 pi over 2, but that reduces to pi. And this is good, because there is the column I was looking for. There's all my key points. Let's take the cotangent. Cotangent. The cotangent is x divided by y, so we're looking at our unit circle. At 0, at 0, the cotangent is going to be 1 divided by 0, which is undefined. At pi over 4, the cotangent is square root of 2 over 2 divided by square root of 2 over 2, so that's going to be 1. At pi over 2, the cotangent is going to be 0 divided by 1, that's 0. At 3 pi over 4, the cotangent is going to be negative square root of 2 over 2 divided by square root of 2 over 2, that's negative 1. And at pi, the cotangent is going to be negative 1 divided by 0, but that's undefined. And then we want to subtract 3. Well, if it's undefined and we subtract 3, it's still going to be undefined. 1 minus 3 is going to give me negative 2. 0 minus 3 is going to give me negative 3. Negative 1 minus 3 is going to give me negative 4. And again, if it's undefined and we subtract 3, it's still going to be undefined. All right, so our ordered pairs at pi over 2 is going to be undefined, so that means asymptote. At negative pi over 4, we're going to be at negative 2. At 0, we're going to go to negative 3. At positive pi over 4, it's going to go to negative 4. And then at positive pi over 2, again, it's undefined, so that means asymptote. All right, let's graph this thing. We'll call this negative pi over 4 right here. And this one can be negative pi over 2. And this one can be positive pi over 4 and positive pi over 2. Negative pi over 2, undefined, that meant asymptote, so let's draw that guy in right here. Negative pi over 4 goes down to negative 2, that's going to put it right here. 0 puts us down at negative 3, that's going to be right here. Positive pi over 4 is going to take us to negative 4, and you guys aren't going to be able to see that point in there, but it is there. And then at pi over 2, undefined, so we have another asymptote on this side over here. Our tangent curve is going to look a whole lot like the negative x to the third curve. So it's going to be rising on this side on the left. We're going to come in here and do a little curve, and it's going to come around here and go down and run alongside the asymptote. And there's our cotangent.